Let's look at this question. Set calculate the total resistance, calculate the total current, calculate in 2 ohms current, voltage in 4 ohm, voltage in 2 ohms, and current in 4 ohms, total power, the energy consumed in 5 seconds. So let's start by calculating the total resistance. To calculate the total resistance, because these resistance are in parallel, so use the parallel formula. So we'll have something like 1 over, let's call this R1, R2, so where there is R1 you put it 2 ohms, which is this one, and then where there's R2 you put 4, then you have something like, and then multiply by this, cross multiply the bottom part. This is R total. This is R total. So we multiply the cross multiply this one, multiply the one, this one multiply the other one, so we have something like 2 plus 4, like this, 4 plus 2, 4 plus 2, and then you multiply this one, you have 2 times 4, which is 8, and then we have 1 over R2, and then we add this one on the top, you have something like 6 over 8, and then from here you have to change, so taking this on top, you bring it down, you have something like R over T, RT over 1 equals to 8 over 6, which is equals to the same as the 2 goes how many times there? 4 times, then 2 goes how many times? 3 times, which is equals to 1 comma 3 recurring ohms. So now we are looking for the total current. This is number A. Going to number B. For number B, we are looking for the total current, because we have a voltage of 5 and a total resistor of 1 comma 3 ohm recurring. So we'll calculate the current by, we'll say current equals to V over R using Ohm's law. Say 5 over 1 comma 3 recurring, so equals to, let's use the calculator, so we have something like 5 divided by 1 comma 33 is 5 is 3 comma 75 amperes. So this is the current, and then current in 2 ohms, so current that passes here So because the voltage is the same here in parallel, so the voltage here and here is the same, we'll just write so we'll have I in I2 voltage is same, so we have something like 5/2, and then the current is 2,5. So voltage in 4 ohms, voltage is the same in the parallel resistor because we already have voltage here. So number D, we have voltage as V here equals to 5 volt, and then number E, voltage in 2 ohms is equals to 2 volt. Then current in 4 ohms, because we got the current here, so the current in the parallel resistor, they divide, the current goes here and some of the current goes there, but the total current is the same in the series here. If here is 2 ohms, is 2 amperes, and also here is 2 amperes, but here they divide. If we have um, 3 amperes, maybe here we have 2 amperes, but when they come here you'll have 5 amperes and in this side. So when they come here, they divide, some goes this side, some goes this side, and after they come here, they combine, they become the same in the series, but here is parallel resistor. So the current in 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 resistor number 4, it's because we got 3,75 on top, the answer you got is 3,75. So we'll write the total minus current in I2, because the current will divide here, the sum will go here, sum will go here, so but the total is the same here. IT, here is also IT, but here is a divide. You have I2, and then you have I for current in the resistor 4. So the total current here is equals to I2 plus I4. The total current is the sum of the two current here, but here is the same, and here this is IT, here is IT, here is IT, but here it divides. So let's continue. So we have IT, which is 3,75 minus 2,5, because amperes. The current in I2, we find that is 2,5 amperes. So use the calculator. Let's say minus 2,5 is 1,25. So the current is 1,25 amperes in 4 ohms. So as you can see, the higher the resistance, the lower the current. So the current will flow this direction will be lower than this one because this side has a lower resistor. So we have to check some of the things that what makes the current to be lower this side and more this side is because of the resistor is bigger this side, and this side is the more resistor is small. So that's why the current able to pass here. It's a lot. So you can see a current in I4 it's 1,25, and then the current in I2 is 2,5 ampere. So it makes the current to be difficult if the resistor is bigger, and then if it's smaller the current flows easily. So let's check number E. Voltage in 2 ohms. So the voltage is the same in parallel resistor, so it will be equals to 5. But the current, as you can see, it divides that's why we did it like this. It's in parallel, this resistor in parallel. So let's check number F. The total power. So the total power, the product of power is current times voltage. So the power is equals to IV. So the total current is 3, the current is 3,7 multiplied by voltage, which is 5. So we have 18,75 watts because power is measured in watts. Let's check the energy. If the energy consumed in 5 seconds. Okay, for the energy, because power it's a watt over, it's a work over time. So we'll have, we want to find the work. So the work is a product of time and power. So we have 18, multiply by 5, then multiplying this 2 is 93,75. joules, because energy is measured in joules. So this is how you'll do it. Calculate. So calculate total resistance. You use the equation for resistor. We calculate this one. Sum the two. Total current. Use the total resistor and the voltage to find the total current. And current in 2 ohms. We use the voltage, which is 5 ohms, which is the voltage in parallel is the same. And then you find the current using the ohms and the voltage 5. So voltage in 4 ohms, voltage is the same, so is this the same as the 5 volts? 2 voltage in 2 ohms the same. Total power is the product of current and voltage. Energy, because we're given time, is the product of power and time. So thank you for watching. See you on the next videos.